It's getting hot here, isn't it? Get ready because I've got some heavy stuff for you guys. Before anything else, I wanted to thank you all because our community keeps growing, not only on YouTube but also on our social media. And for those who are new today, feel free to subscribe and follow us on both YouTube and socials. And now, let's talk about our tutorial. So today we are diving into fluids and simulation. Have you created fluid simulation in Blender and struggled trying to export them to Unreal Engine using the Alembic format? I'm here to save the day, guys. First, we need to think about exporting part of the set from our environment in our Unreal project. This is something commonly done in production, especially when the set tracing is done in Unreal, but the general simulation is enrolled in Maya or Blender. We will also need to export certain elements here. It's quite simple, just select all the desired elements in our level.
Do we have to select each actor individually on our scene?
Remember, Matilda, proper organization of your actors is crucial. Since we didn't create this environment and it wasn't designed for this specific use, we indeed need to select each element individually here, especially those affecting our simulation in terms of collision and path for our fluid sim. Creating specific folders in your Outliner would have simplified this step for sure, Matilda. Once everything is selected, navigate to the Actor tab and find the Merge Actors attributes. Here we have several options. Note that we can merge our selection in Unreal either completely or in a simplified manner, with even a voxelization pass to reduce the final file size for exports. For our needs, respecting the collision information of each actor is essential, so I'll choose the Merge option. This will create a single static mesh without simplification, while also respecting the materials assigned to each mesh. You can also adjust the merge parameters in the Merge Actor settings if needed. Let's specify location and name for our future merged mesh. After a few seconds or minutes of reading, depending on the size and number of selected actors, we'll have a single asset gathering all our prior selection.
Can we easily export this kind of asset for import into Blender then?
Yes, Sophia, and it's pretty straightforward. Right-click on the asset in question and under the Asset Action tab, you'll find the Export function. As you can see, we can quickly export our asset in the classic FBX format. So now our initial setup on Unreal is done. We can now import our mesh in FBX format into a new Blender scene. The setup process here is quite standard. I first create a simple cube, which will serve as the domain for our simulation. After placing and scaling it, remember to always apply transform to ensure a proper base. Otherwise your simulation might not behave correctly. Let's add a fluid physics attribute to our cube, specifying it as a domain of type liquid. Next, we can use a sphere as the emission source for our fluid sim. Place it in position and again don't forget to apply transform. Sometimes rotation and scale will be enough, without needing to apply the location. In my case, just the first two attributes gave me the desired results. We'll also add fluid physics to the sphere, but this time as a flow type. Set the flow behavior to inflow to continuously generate fluid. So now when dealing with our exported mesh, we need to specify certain things for Blender to account for it in our simulation.
But Stefan, should we add collisions to this asset? Does Blender understand it automatically?
There are several ways to handle this, James. The simplest solution is to add a fluid physics attribute to our mesh, as we did before. This time, we'll use the effector type. This type allows Blender to use our mesh for collisions during the simulation. Add some surface thickness to prevent the fluid from passing through our mesh. To further avoid fluid passing into unwanted areas, I add another mesh as an effector to block those parts. I'm using a fairly coarse simulation in terms of domain. By fine-tuning this, it could be more precise and less heavy to compute.
By the way, will this take long to compute? I imagine it's not real time?
And you're right, Sam. We might need several cups of coffee if we want a very detailed simulation. It's up to us to decide. For example, here, I kept it simple and just increased the resolution without exceeding 500. Everything else is set to default, as you can see. I haven't added any particles like spray or foam. And if you want to add this, be cautious, because remember, the Alembic format does not handle particles data well and can't export them effectively. And we will talk about that just in a moment. Now to export our simulation, we need to bake it. Under the Cache tab of our domain, the default option is Replay. This means we bake the simulation by playing it directly on our timeline. It is simple to set up but can be slower for more complex simulations. Another option is to choose a modular bake with the Is Resumable option to bake in stages, like baking the fluid particle first, then the mesh attributes to create geometry, replacing the particles. and now it's up to you to decide what best for you, of course. After several tests and setups, I'm satisfied with the final results and can now export my final bake. Here we only export the domain, there's no need to export the inflow sphere, for example. Our sets will still be present in our Unreal scene, so if you haven't changed the scale, you can quickly align the simulation one more time. Select our domain and choose to export it in Alembic formats. Once in the export window, first ensure our simulation scale is set correctly. By default, the Alembic file exchange between Blender and Unreal requires ×100 scale conversion. This is likely because Blender uses meters, while Unreal's default unit is centimeters. Make a quick conversion here, or your simulation will be really tiny. Now make sure that your frame start and end match the timeline we set earlier and check the selected object attributes to export only our domain containing the essential data. You can leave everything else as default and it will work well. Just uncheck the particles attributes below as mentioned earlier, since Alembic doesn't support particle system effectively. Hair is exported as animated curves with 0 thickness, and all the particles as animated points, which aren't useful for our purpose here.
What if I want to add foam or spray to my simulation?
The easiest way, Sophia, is to use another export format. The VDB format is most suitable for this. There's a lot to talk about it, so I'll likely make a separate video to clarify everything. After exporting your simulation, time to go back to Unreal. In the content drawer, import your Alembic file straightforwardly. You quickly see the Unreal import window for Alembic files. There are several options and import types available. For our needs, we want to import the entire simulation as a single asset with its baked animation. Typically, in Unreal, we use the geometry cache import type in such scenarios since we won't be modifying the simulation itself. We'll just place it in our scene and add a nice material. This format is widely used in production, especially for character animations created in Maya or Blender. When animating characters in other DCC tools, we often use auxiliary tools for animation data that can be exported and stored in the traditional FBX formats. The geocache method encapsulates everything neatly and efficiently.
That's great. So why bother with the FBX format then?
There are several downsides to using Alembic geocache format, James. Firstly, as I mentioned earlier, with this format you can't adjust or modify your animation in Unreal. Everything is baked and you can only play the animation track. Secondly, the file size of the imported asset is significantly larger. Lastly, don't forget that the geocache is read directly by our CPU, which is also something to consider. Returning to our import window, ensure that our frame start and end matches our initial export from Blender, and leave all other parameters at their default settings, which should work fine. Maya's conversion settings are sufficient for our case here. Now place our geocache asset in the scene and play its animation as desired, either by launching a specific game mode like third person or using a sequencer to call the track of the geocache animation and adjust it as needed. I also quickly added a custom material to give the final touch to our simulation. And here you can see our final result using Blender simulation imported as an Alembic format geocache in Unreal. So we have a direct workflow here, using many default parameters without needing to tweak multiple settings in Blender or during imports in Unreal. You can make a quick and really nice fluid simulation in no time. That's really great, guys. I hope this video helped you guys how to set up a Blender simulation and to export it as an Alembic format in Unreal. Don't forget to leave a like, subscribe to the channel. Thanks again, guys, and see you on the next video. Ciao!